Thank you, and thank you, Jason, and thank you to Skookum Digital Works. Really appreciate the invitation to come and present here, and I'd like to thank all of you for coming to listen to what I have to say today. As you mentioned, my name is Mack Coyle. I'm with Coyle Industries. I'm the founder of the company, and today's title was Disruptive Innovation, Decentralization, and the Corporation as a Tool of Ecology. And you're probably wondering how I came up with such an inflammatory title. I did a word search on what was the biggest buzzwords in policy and business circles, and so you guys are among the elite. You recognize that. But all joking aside, our product is a disruptive innovation, and it seeks to displace existing business and businesses that already have products that are meeting a human need. And the definition of a disruptive innovation, it was a term coined by Clayton Christensen, and it basically describes a process by which a younger and less capitalized competitor can displace a larger company that seemingly has all the advantages. And I recommend that everyone look into Clayton Christensen, find out more about his theories and his business philosophy. So decentralization, it's the opposite of centralization. It seeks to distribute administrative function and powers to local bodies or to people themselves. And our product does that intrinsically. It turns over generation and distribution to the individual, so it decentralizes the control of electricity distribution and water distribution. So, and in terms of ecology, that's the study of the natural world, how we participate in it. And our machine seeks to provide a better, more environmentally sustainable solution to power delivery and water delivery. So our device has embedded in it ecological precepts. And the corporation is a legal entity, a business, but it can also refer to a group of people that are working on a similar project or in a similar way. A little bit about our product, the CM4 Workmate solar generator. It falls into this category of disruptive generation, and as I mentioned, it decentralizes power and water distribution, and it changes consumption habits and human behavior in a good way, or a positive ecology. So a little bit about myself. My name is Mack Coyle, as you've heard several times now. I grew up in Berkeley, California, and it was a wonderful place to grow up. I was exposed to a lot of ecology philosophy, and as well as environmental activism and activism of all kinds. My parents were both radicals. They taught me to take ownership of this world and to fight for it. And I've been doing that my entire life. My father is a doctor of economics. His expertise is in power rate design and in utility rate structure in general. So I had a lot of exposure early on to economic philosophy and also to the nuts and bolts of electricity. He would take me oftentimes to geothermal plants, to PV, to solar, thermal, and to wind generation facilities, as well as nuclear and conventional generation sources. So my professional background, I don't have a degree in engineering. I'm not certified as an engineer in any way. I'm a professional construction worker. I have a lot of experience in plumbing and in carpentry and in project management. And I grew up being led into an outdoor lifestyle, and so I have a lot of experience in outdoor education, as well as outdoor living and wilderness survival. And I spent a lot of time living out beyond the edge of the road. And that's where a lot of the practical knowledge came for building this machine. So, and the machine. That's how it started. I called it the machine, and a friend of mine asked me to see if there was a realistic opportunity to build a self-powered water purification machine. We had, like many inventions, we had been drinking beer, and so he asked. He had a property in the British Virgin Islands. They couldn't get an operating license. The water had been allocated for 10 years going into the future, and there was no chance that they would be able to operate their business in the near term. And so I had said, oh, it's easy, make a self-powered water purification machine. We had been building our own water and power systems. I knew a little bit about it. And I became obsessed with it. I started looking into it. There was no money. He wasn't going to fund me to build it, but I was obsessed with it. And I throughout my experience with Coyle Industries and with the machine, I would reach out to people and make connections, and that would propel the entire endeavor forward tremendously. And one of those people was a man named Don Steely with Flex Charge. And he built a flex, what they call a flex charge controller. And it's different from what almost everyone else uses now. They refer to it as an MPPT. That's a maximum power point tracking. And this has a lot of advantages, especially when you're building arrays. But when you're dealing with a single source or a single module, there's a lot of advantages to tailoring the flexing, the charge control to the voltage of the module. And that's one of the aspects of our device still today. So what ended up happening is everyone was really annoyed with me talking about the machine. I was drawing all the time, making drawings of it, and my business partner essentially challenged me to build a machine to power his wedding, which was on a remote beach in California. And so I did. That was the first machine ever, and that was 8 years ago, over 8 years ago, almost 9 years ago now. And the machine, I finished it the night before. We got it on the truck. We drove it out there. It powered the wedding. The reaction was just incredible. Not just the people at the wedding, but people at the campground were coming over all the time saying, "Is that a solar generator?" They didn't need to have an explanation about what it was. It was obvious to people. And they also all saw it as something that had real potential to be a product and to be sold quite widely. And so there was a problem, though. The machine doesn't work. And it broke in loading it onto the truck for transport. The substrate, the trailer we used, was too weak to accommodate the weight. So it literally broke into pieces as we tried to put it on the truck. And although it operated and powered everything, it did it for that evening and that day, and they actually ended up using it for the rest of the weekend and had a big, long, extended party. But it was an inoperable design. I had to be there to make sure it was operating. It was dangerous design. I had come up with this, what I thought was a clever way of orienting the panels, and I just made it out of simple EMT, which is a magnetic metal tube for protecting cable, electrical distribution. And so it was very dangerous. There was pinch points you had to be aware of, and all of that broke as well. So I brought it home, I rebuilt it, put it on a new trailer. It kept being destroyed, and I eventually built it to where I thought it could survive. I had some new features. It didn't have adjustable array. So I loaned it to a friend of mine who was an electrician. He worked for the telephone company, and he wanted to take it to Burning Man, which is an event out in the desert. It's an arts festival and alternative living, lifestyle, alternative thinking. And so he took it to there. I explained to him, look, this will recharge tools. It'll power certain things, but it's not going to run, your camp or anything. It's going to repower your radios or repower your cordless tools. He said, "Oh yeah, I got it, no problem." He brings it back, and he had burned up the batteries. They connected it to a huge string of Christmas lights in a disco. They had set up a roller disco out there. And so it boiled the batteries off, fried the electrolyte, destroyed the batteries. And this was very expensive. I'd already gone through several rebuilds, and in the beginning I was hedging my bets. I had a ski boat, and I had a 4x4 Suburban, and I had a race car. And so I was buying stuff that I knew I would be able to use in my other projects. But I realized when it came back that two things. One, you can't have any education necessary to use the device. If the end user has to be educated, they'll destroy it immediately. And two, you have to buy the components that of the highest grade. You can't rely on it to operate at its 100% capacity, because it fulfills the old premise about the weakest link in the chain. And so as soon as one component broke, the entire device was inoperable. And if they were all expected to operate at 100% capability, it was going to break immediately as well, just from the componentry. So I kept rebuilding the device, and the machine works. I finally have built a device that worked and was sustainable in its operation. We called that machine the CM1. And I built that from my family farm out in New Jersey, Cattail Farms in the most southern part of New Jersey. And there was clear advantages of the new design. It does not just demonstrate or do it once for the event. It works. We energized it for the 4th of July party we were having. We had the party, it powered the music. And then my stepfather took the device out right then that evening and put it out in the field, and it was in use for 18 months continuously, pumping water for our farm. We were in a bad drought in New Jersey. And this was the first machine that actually had all the components that I had first envisioned. It would It would generate the electricity, it would defend the battery. When the battery was completely charged, there was an integrated shunt circuit so that we could leverage the ROI. In other words, when the batteries are full, the panel is idle, it's one of the most expensive components, and your ROI changes dramatically. So by including an integrated shunt or a dual primary use, you can leverage the cost and force the ROI. So there was clear advantages to the new device. The first one being that it worked. And the other was that I now was orienting the device itself. The panel was integrated into the machine, and so you didn't have to adjust the array. And this actually was one of the best innovations that we came up with, is that the device, that answers a lot of problems that everyone faces with PV generation. So, and as it turned out, that was where we probably had our strongest chance of getting a patent protection. And as I get into the story, you'll find out that we weren't able to achieve that. But so I built another device in California, which we called the CM2. It was slightly larger, didn't include the pumping unit, but it had a larger inverter. It would actually run equipment. We could run a skill saw or common light industrial tools. And I approached a friend of mine, Adam Cohen, who was an angel investor and worked with an organization called the Angels Forum. He's a very successful businessman. And he gave me some advice. He told me, one, you have to form a business for anyone to talk to you reasonably about this. Two, you have to demonstrate that you're investing your own money. And three, you have to build a working prototype. So I took that advice. I went out immediately and formed a sole proprietorship, formed a business. I already had invested my own money. I was the only one doing it. Everyone had told me I was crazy, that everyone knew that solar didn't work. And I set about building a new prototype. But it was very expensive, and it was ruining my life. I was about to be married. I had big life changes coming on. I was getting rid of all my toys, as I mentioned, the off-road equipment, the boat, all that kind of stuff. And but along comes investors. I had a very good friend who had been an activist. We'd lived in a collective or a commune together, working on social justice activities together. And he had been, we'd both gone our own ways. He was a businessman in Oakland, and he sold the warehouse that he owned, and he had $40,000 in cash that he wanted to invest in Coyle Industries. And so Coyle Industries, a little side note, Coyle Industries, I named it that because I was doing construction, I was plumbing, I was doing carpentry, I had a construction services business, and I also had a garbage hauling business. And so I decided to name the business Coyle Industries because I had several businesses already, and it was a natural fit to go from garbage hauling to high-tech manufacturing. So, I named it Coyle Industries kind of tongue-in-cheek, and it was a joke amongst my friends, and everyone still thought I was crazy, but that's how I knew I was right. Everyone, 100% of the people told me it couldn't be done, so I knew I was right. And so I kept working on it. Matthew Quirk, I told him, look, that's going to lose all your money. I'm probably moving to North Carolina soon. He said, let's do this. I think we can really make some money doing this. And so with his $40,000, we formed an LLC, and we began building a fleet of new devices, the CM3 and the CM4. And this is a CM3 and CM4 right here. We built a fleet of 5 machines, 3 with the pumping equipment and 2 without it, just as a Powerhead. And so we had a debate about where to first demonstrate the project, or the product, excuse me. And everyone was recommending that we go to Earth festivals or the Health and Harmony Festival, but I knew that this equipment was very particular. It had to be people that used equipment all the time and knew that function was very important. It wasn't just an aesthetic or a philosophical thing. It had to be equipment that people would purchase and use. And I thought that my other subset, rednecks, this would appeal to them very much so. And so we went to what was called the International Sportsmen's Exhibition. And this is an international event, but in the United States, it's primarily for safari companies to come and drum up business. And then all of the other attending businesses or vendors are there as well, selling guns and knives and all the things that you would use for outdoor living and outdoor lifestyle. And but the reaction was incredible. Just like at the wedding and wherever I went with the machine, the reaction was just incredible. People didn't need to have it explained. They saw what it was. And at the Sportsman's exhibition, we were running chainsaws, and we had set it up so it would pump water from one horse trough into another. And we had a sometimes we had a crowd 6 people deep at the event, and so much like this one has been reworked a little bit, but much like this one, you can tell that it was built in a substandard garage basement in Berkeley, California. And people were interested in buying them, but they were sizing us up and looking at it and saying, you know, if you guys built it, I bet I could build it too. And so we didn't ever sell any of these machines at the event. But the reaction was incredible. And I had another friend, Jeff Lipton, who had provided the sound engineering for the wedding and had been very hesitant about relying on the machine to power the music, and had brought a gas generator to the wedding to hedge his bets. But he came down to the ISE, to the International Sportsmen's Exhibition, to see the reaction. And when he saw how people reacted to it, and in particular this group of people, he decided to invest as well, and he ended up being my second investor. He was a very much more accomplished businessman. He had just graduated from the Haas School of Business at the University of Berkeley, and he shepherded us through the next stage of development in many ways. Now, I was moving to North Carolina. Both of these friends of mine had just invested their life savings, and then I announced that, in fact, I was moving to North Carolina. So that was a difficult consideration, but it was something I had to do for my family, and it turned out to be the best thing that could have happened to Coyle Industries, is moving to North Carolina. You know, I came here with a lot of hardened prejudices and stereotypes about the South and North Carolina in general, and they were dispelled, you know, with great rapidity, and over again they've been proven false. I came to know that this is a community of people that are involved in the highest level of technologies and innovation, and as I said, it was really important that I moved here. I moved here, I was still talking about the machine. I didn't have any of the equipment now. I just had some of the brochures, which some of the old ones that I can pass around after I'm done, and you can take a look at them. But I was passing those around and talking to people about the equipment, and I made through a series of introductions, I made the acquaintance of a man named Jim Starr, who was an engineer, and he had a company called Tautex that helped companies like ours develop new technology or new combinations into products and get it ready for manufacturability. So I was already planning to return to California to make a pitch to the Angels Forum. Adam Cohen had arranged for me to come and make a pitch. And so I was already returning to California. I arranged to meet with Jim Starr as well. And the day before I left, he called to ask if we could change our appointment. He had some associates coming from Singapore, and he would like to introduce me to them when we all met. And so in that meeting, I met with the gentleman from Singapore. They had studied here in the United States, and they had worked extensively with Jim Starr. They had a company called CEI, and they were a contract manufacturing company in Singapore. And they did high technology, high mix, and high volumes. And they were looking for people they were looking for business for their company. They wanted to find products that they could manufacture over there for companies here, and so they were in the United States drumming up business. And so this is the first sign from that we took to the ISE, and I don't know if you can read it. It says, "Tested by rednecks, approved by hippies," and so and even that we were arguing over. You know, that's insulting. My partners were saying that's insulting. You shouldn't use that. And I was like, well, who's it insulting to? You know, and but anyways, as it turned out, everyone loved it at the ISE, and that was one of the questions we kept getting was which one of us was the redneck and which one of us was the hippie, because we both had beards at the time. And so, the meeting with CEI went really well. They are the ones that actually asked me if I had ever heard of Clayton Christensen, and I said no. They told me a little bit about him. They had had direct contact in business with him, and they knew him personally. And they explained that they thought our device fell into this category of disruptive innovation. It could displace existing markets, that we didn't have to develop a product for a non-consumption market. We could develop it for a consumption market, something that already exists. And they thought that was a very strong way forward to make money, was to take on an existing market rather than try and create a new one. So I said, well, I'll look into Clayton Christensen. I don't know very much about him, and you know, I'd never heard of him, but my friend Jeff Lipton had read his books, and this turned into the first sale of the machines. We went out and we went and took a look inside the machine, and when I took the panel off, they burst into laughter, and they all started talking in Chinese, and I was a little embarrassed. I said, well, what is it? You know, and they were literally like holding their sides and bending over, laughing so hard. And I said, what is it? And he pointed and he says, it has plywood in it. And I said, oh, plywood, I love plywood. It's a great material. But it's not a manufacturable design. But they were still impressed with the machine, and they explained to me too that they could find engineers, they could find accountants, they could find people to run the business. What they couldn't find is people that think differently. And they thought I was thinking differently about the problem, and they thought that had value, and they would like to support what we're doing. They agreed to buy 2 machines. So with the money that they provided, we immediately began engineering with Jim Starr and a man named Jerry DeWitt's help. We began engineering the machine for the first time. And we made a design that is similar to this in its componentry, but very different in its form. And so it was engineered. It had a manufactured look. We were still making it by hand out of tube steel, cutting and welding it all ourselves. And we manufactured 3 machines of that, which we called the CM3, and it became CM4. But we shipped those units to Singapore. We obligated our agreement with them, managed to ship the machines there. My father, Dr. Coyle, had been invited to China by the man who was running the electricity distribution grid in China. And so he was going over there. He was going to transit through Singapore. And so I said, well, this is great. I called up SCTN, the president of the CEI, and I said, I'm sending out a representative. And they said, oh, really? They were impressed by that. I said, well, who is it? I said, it's Dr. Coyle. And they said, oh, Dr. Coyle, great. And they obviously looked into him, and they came back and said, oh, we're really excited to host Dr. Coyle. And I said, oh, he's my father also. And so they were tickled by that as well. And so he went and met with them, and they took him on a tour of the facility, and he ended up meeting with them on the mainland as well, and we established a very, very good relationship with them. But as it turned out, the machine doesn't work. So as soon as they got it, they began fail testing, and that means they started trying to break it or just use it in the way in which we'd prescribed. And so it started breaking. The inverter burned up. The charge control method, we had changed our operating voltage, and it turned out we had made a very basic error. And so it was only getting half of the current that we thought. And so they started to help us with the redesign and the rebuild. And they were very, very, very helpful. A wonderful company. I can't recommend them enough. SCTN and Kuwait are very generous people. And eventually we had a successful operation of the machine. The machine, we kept sending them out components and burning up all the money that we thought we had made in building these. But we were able to maintain a very strong relationship with them. Successful operation. They conducted some very structured testing of the device and provided that information to us, and eventually had the device run through some field tests with the Heavy Armor Group of Singapore, which is, as I understand, is their Air Force and Marines. But so the machine works. We now had a working machine again. We had solved some of the critical problems in our electrical engineering. They were very simple. It was a matter of just changing the voltage in the charge control method. And we engaged in a 5-unit build of the CM4 with the new design. And this was with Jim Starr and Jerry DeWitt's help again. They coordinated all the engineering, and we were now building it out of folded metal. We were focused on a design for manufacturability philosophy, and that drove the entire development of the machine. Unfortunately, we weren't able to get the other machine up here. I have 2 of them. I have one of the CM4s that we built from that run downstairs, and we can go and take a look at that together if you like, and we opened up that machine as well. So we cannibalized the CM3 fleet. This machine was cannibalized, and all the other machines we were saving money, we're cannibalizing the machine. So many of the components are 5, 6, and 7 years old now in the CM4 and in the CM3, which is, I think it's labeled as CM4 on there. So with the new machines, I brought 2 out to California in February of 2010. I began demonstration of the unit, and that led to rentals and to sales and to powering music events. And that's actually how I met Jason Daly. We were doing a demonstration at a restaurant down there, the Mellow Mushroom. He saw the machines. He called me up. He said, I really want to talk to you about this. I love the product. I'd like to help you in any way I can. And Jason, I'm not sure where he is now, but he was an incredible amount of help. He actually went out and found our first real paying rental job, and it was a large surf contest, the Reef Sweetwater Surf Contest. They had over 15,000 people there over the weekend, and we continue to power it today. We have a very good relationship with them, and it's become because of Jason going out and beating the bushes to find the tigers. So, and the machine is a great calling card. Everywhere I go, people love the machine, and you don't have to explain it to them. People see it, they're like, wow, that must be a generator. And so local greens, quote unquote green community, the Cape Fear Green Builders Association, other associations that are focused on ecology and environmental justice, were thrilled to have this device. We were powering their events, and we engaged in mutual aid with all these other organizations. And also began to realize that I was going to have to be a businessman in a very real sense. I couldn't just be the mad inventor anymore. It was going to be up to me to show people that this was a safe, a risky, but a viable business. So I got involved with the Business, Industry, and Government Center at Cape Fear Community College, and a man named Doug Tarble runs the center there. Excellent resource as well, and he helped me in tremendous ways. He got me engaged with the military trade show circuit and FEMA, and through that I met a variety of vendors and manufacturers here. And again, the machine was a great calling card. Everywhere I went, people were interested in it. I didn't have to introduce myself in a cold call manner. So it was wonderful having the machines out here. And I started pitching it to VCs here and to all around, and the response I was getting was very similar all the time. Show me a validated customer. Everyone wanted to see that I had somebody that would buy this in volume, or that there was somebody that would at least entertain the idea of buying it in volume. And so I was getting a great reaction to the trade shows. I started to work on engaging with the federal government so that we could sell to the military. And this is a very complicated and nuanced thing. It's not something that you can take on in a casual way. This whole time I'm working full time. Also, I had 2 small children, newlywed, and I was rebuilding a house that we'd come out here. So I was very busy. But that kept coming up. Show me a validated customer. And so we're going to the trade shows. We're engaged in mutual aid with all these other organizations. It was getting an enormous amount of exposure for the machine and the company. I came up here with my associate and friend Rick Groves back here. He's the executive director of Clean Energy Events. Raise your hand, Rick. So yeah. But Rick founded the organization Clean Energy Events to promote and inform people about alternative energy generation and distribution. And Coyle Industries works very closely with Clean Energy Events. So I also, through Clean Energy Events and seeking mutual aid with other organizations, I was trying to find other groups that we could provide the power to. And I met a man named Mark Mosier, who was a retired Marine. He had been in force reconnaissance and been in the Marine Corps for 27 years. And he was very interested in the machine, wanted to become engaged, and started to work with us directly, eventually becoming the director of business development, and worked with me for over a year. And he had a lot of experience with the military, not so much with selling to the military, but how the military mind works, what they would use the equipment for, how he thought they would envision it. And he was a tremendous help, a tremendous asset. And and he recommended that we get involved with an organization called the North Carolina Partnership for Defense Innovation. And they take products that have dual use or might have a military application, and they shepherd those companies through the process to selling to the military. And they essentially have a process where they prepare you for what they call a defense authorization audit. And this is very in-depth audit of your business, and if you don't survive the DAA, you don't get the contract, even if you've signed the papers and you think you're going to get the money. So they also, though, have a giant laboratory, and I often refer to them as the spy laboratory, because they tested all the radio equipment for the military, and they tested any kind of new equipment. They had atmospheric chambers and all kinds of sophisticated ways of evaluating stuff. So we brought the machine up there. We became a client of theirs, and we brought the machine up. We opened the machine up, and it was something we hadn't discovered. There was a fatal design flaw in the machine that would eventually destroy every device. And so they also helped me understand that we had very serious corporate governance issues, that I needed to be more on top of running the business and understanding that the books were just as much a part of the business as the product. So those were both very difficult obstacles. And so we retrofitted the machines, we corrected the design flaw before any more machines were destroyed, and they continue to work today. It was a simple mechanical engineering problem, but at this point, we had run out of money. We had already run out of money a year earlier. And because I was having difficulty in addressing the corporate governance issues, on paper, we had this phantom tax burden that was enormous, $400,000 in tax burden just to Delaware, where we had incorporated. And that's on revenues, I think, of only $35,000 or $36,000 over 3 years. And we didn't have the money to file the taxes to get the stuff addressed. It was a huge problem. I couldn't even go and talk to anyone anymore about the business because we were defunct. And so that was a huge problem. But I had already agreed to present at a UNCW event called the Rocket Pitch. And this is an entrepreneurship center sponsors this event. And so I went to the Rocket Pitch, and it was clear that we were going to have a lot of problems overcoming this without any money. And I went and made the pitch. Tremendous reaction. Everyone liked the business. I didn't mention that we owed $400,000, and everyone loved it. And a lot of the things that we were presenting there really resonated now. We had originally been focused on contract manufacturing, where we would take our design collateral and we would be able to manufacture it wherever the sales were going to be generated. And we thought that was a very sustainable model, lower the costs. But as it turned out, through the design work, it was cheaper to build it here in the United States, and it was cheaper to build it here in North Carolina. And in fact, it was cheaper and better. We would end up with higher quality. And so the product now is 95% North Carolina sourced and manufactured, and 100% United States content and manufacture. And that was that was something that we revealed at the 2011 Rocket Pitch, and it resonated with people. But what ended up happening is I made a lot of connections at the Rocket Pitch, and one of the people I met was a CPA named Steve Rizzo, who agreed to come and help me. And he continues to help today. We're finally resolving all of our tax issues all this time later. And that was a big development. It was really important that I continued on and went to the Rocket Pitch. And I also booked 2 meetings with VCs out of that. And so I went to them, and I was expecting to hear the same problem, show me a validated customer. And I was startled. They both used almost the exact same language, and they said, and that quote essentially that emerged out of that was, you need a proven jockey in the saddle. They said, we like the presentation, the product, the way in which you're describing how the business would run, but nobody is going to just hand you a bag of $3 million. And so you need to have a proven jockey in the saddle. And when I met with the second VC and I heard almost the same exact language, I realized that this was a new stage I was at. I had gotten past having to validate the product as a saleable item, that in fact we had crested to a new plateau. And so that's where we are now. We still need a proven jockey in the saddle, and I've been looking for the right person and incorporating that into our seeking investment. But we were out of money, and we were dead in the water. We were going to have to declare bankruptcy for the organization and disperse what equipment we had. It was unclear what was going to happen, but a small investor saves the day. Somebody emerged who had been thinking about making an investment, and at this time we had been trying to seek large investment, $3 million, but we had also been seeking money from what's known as a bridge loan or a convertible note. And we had one convertible note contract we'd executed, and this investor emerged. He wanted to invest $20,000 in a bridge note, and that saved the day. Essentially, that allowed us to pay off the immediate bills that were crushing us, and to reorganize and to move down the process and filing the taxes correctly. And we eliminated the tax burden in Delaware. We reduced those all down to zero. But the team is demoralized. We're out of money. We haven't been able to get any sales traction in a meaningful way. We have no working capital. We have no time to work on it. Everyone has had to go back to their regular jobs and to their families. And this kind of highlights one of the things that I've made in presentations about this in the past at the ITT Institute, and is that I'm not sure if you guys are familiar with Virginia Woolf, but the title of this book is A Room of One's Own. And it's an essay about having to support the arts, and essentially it's about writing and the problem that women were facing in terms of becoming writers or successful as writers, and is that you have to be supported by the community. You have to have the support of the community to achieve anything, and this is very true in invention, innovation, and in business. So So once we had established that we were going to survive, I'd continued working on developing relationships with manufacturers and vendors here in North Carolina, and so we have survived, and we're raising money again. We're moving forward. Well, some of the advantages of the Coyle CM4 design is it's unitized and it's orientable, it's robust, and there's no user education necessary. It's not so much that they don't have to be instructed on how to turn it on. They don't have to understand how electricity functions in the system. They don't have to understand about gasoline or fire hazards. It's very user-friendly, and that's a very important attribute of our device. It's automatic in its defense. It shuts down to protect the batteries. It won't allow the batteries to be overcharged. And the power level meets the need. So finally, at this stage, we were able to power a small job site. It would handle light industrial tools. And it's mobile and portable, so you could buy the solar power and then bring it with you to where you needed it. And then we have some trade secrets, which I'm going to expose here in a few minutes and let you guys steal them all. So now the problems facing PV are very similar on the micro and macro level. PV arrays or modules are usually constructed in arrays on roofs, and they're wind vulnerable. This is one of the problems that has been plaguing tracking systems and other elements of adoption of photovoltaics. So they're wind vulnerable, and that's a big problem. Also, the orientation of PV for optimal generation is very important. The device wants to have a 90-degree angle of insolence if possible, so that the photon strikes it and it can't bounce off and escape. The way in which the PV phenomenon works, the photon strikes the silicon, it saturates the silicon, it dislodges and excites an electron that moves and forms the electrical current. So orienting the device is very, very important, and then ease of operation, system balance is very important. And obviously, you need the array to match the consumption, the load, ease of operation. When you have a fixed array, all the stuff is generally handled by somebody else, a qualified electrician. So for macro, it's important to have ease of operation for reducing ongoing costs of O&M, operation and maintenance. And then function, it has to actually work. And this is something that's plaguing macro PV also, is that one of the modules will fall out or it will lose power producing capacity, and it doesn't work. And so there's a lot of problems that are very similar between micro and macro. And so this is the design philosophy that we still focus on at Coyle Industries, and the problem is the solution. The wind vulnerability, the form is the function here. The device itself is the array, and it is ballasted by the batteries. And so the device has a high level of wind invulnerability now. It can survive over 120 mile an hour winds, and it turns what people had seen as problems in developing a portable solar generator into useful attributes, and that's the ballasting of the machine with the weight of the batteries. When you discuss it with people, they say, oh, well, the storage problem is intractable. The batteries are too heavy. But in fact, we need to have that weight in the device. And so it's turning the problem into the solution. Again, orientation, the device is the array. It's imminently positionable. And this is leveraging the form of the device as well. We already have a very robust chassis and pivot point, and the device is weighted in a certain fashion so that it's easy to orient for a single person. Again, the problem is the solution. The storage, everyone says storage is a problem, and I disagree. I don't think the storage is a problem. I think it's a matter of engineering and capital. And this is being borne out by what's happening in the macro scale right now. Utilities are building large batteries, and they're focused actually on lead acid batteries. So that's an important aspect of our device as well, is utilizing what's known as COTS, commercial off-the-shelf equipment. So. And then going through the rest of these, you can read them. I'm sure you already have, and I'm boring you. But the most important one is to accept the design parameters of the commercial off-the-shelf products. And this goes back to operation of the device at 100% of capability. You have to recognize that the components will function, and if you utilize that functional parameters, you can build a machine to meet the workload, to meet and do the work for you. And this is a very important part of how we approach the problems facing both portable solar generators and distributed generation in general. So So what's next? Portable solar generators. When I started out, I thought no one had ever thought of this, but as it turned out, in our patent search, I found information on patents that have been filed in 1972 and 1978. And in fact, when I looked at the drawings, the abstracts, they actually had the same drawings that I had come up with. I first started thinking I would put it on a hand truck and then an appliance dolly, and in fact, those were the drawings that they had done as well. And so portable solar generators are here, and they're not going to disappear from the market. People recognize the utility. There's dozens of people that are manufacturing them now, and there are a variety of competitors here in North Carolina that emerged as soon as they saw our equipment. They say, "Hey, that's a good idea. We should do that too." And I encourage everyone to do it. And I would be happy to help anyone in any way I can. But as I said to that competitor, I was a little annoyed. I won't lie. I was a little annoyed. I said, it's more than just panels and batteries. So, but what I see next is that we're going to be seeing heat to electricity, and this is driven by one of the issues with PV generation is the temperature coefficient. And I don't see that as a problem. I see that as a solution to power generation. At the bottom, you see it, the problem is a solution. The heat, quote unquote, represents more available energy than the photon. And actually there, it's the same thing, it's energy. And the heat interferes with the ability of the silicon to be saturated by the photon and to dislodge the electron. So and people are working on this in a variety of ways, cooling the panels, and one of the issues is that it ends up hot spotting, what they call hot spotting. And so one silicon wafer will hot spot, and that'll drag down the whole string. The string will drag down the module will drag down the array. And so temperature is a big problem that people see in PV. And the answer to that is to see it as a resource, to draw that energy off of the panel itself. And what we're working on now, and what I see as a viable way forward, is to use combined cycle heat pump, an AC unit, gather the heat from the PV array. That gives us a productive, a recursive input, which is cooling the PV to make a higher efficiency, longer lasting panel as well. And then driving that collected energy through the AC or the combined cycle heat pump, driving it through the TEG and TEC, getting the 9 to 10% of recoverable electricity from the technology. Excuse me, does everyone understand what I mean by TEG and TEC? That's thermoelectric generator, thermoelectric cooling. And this is the Seebeck and Peltier effect or phenomenon. And this is a solid state device, just like the PV array. It's a solid state device. And so we're focused on utilizing that heat to address some of the other issues that we've found in the components that we're incorporating now in the next series of devices. We have a larger power production level in our new device, 3 panels this size in a less than 1 minute deployable array. That power level will now allow us to build what I had originally set out to do, which is a self-powered water purification machine. I could build demonstrations of it, we could pump water, but at this new power level with 3 modules, we'll be able to not only pump the water, purify the water, but also keep the batteries fully charged every day. It'll run off the shunt mode, and we're finally at that power threshold that'll allow us to have that dual primary use. And moving towards that, we're going to be incorporating atmospheric water generation, and this will be part and parcel with the AC cycle, the heat pump. There's problems with the dew point optimization, and so TEG and TEC has been focused on waste heat and in changing the thermodynamics of existing equipment. Usually it's attached to drive mechanisms, transmissions, engines, exhaust. So. All right, I'm sorry I went so long. Thank you very much for listening to me. I appreciate it very much. Okay. And here's some demonstrations of the larger devices that we're going to be rolling out in the near future. This is the CM4E. This is on the same footprint and size as this trailer. And this will be incorporating the water pumping capability, the atmospheric water generation. And a side note on that, the atmospheric water generation is an air conditioner. It runs the air over a coil. The water condenses out of the air. It collects the water. It purifies the water and delivers it as drinking water. But we're going to be using that as a recursive input as well. One of the things that the Army or the military really wants is to be able to have dry, cool air, and that's actually why they want the portable solar generator, is to run the dry, cool air. So we're going to actually be generating water with it on the shunt circuit, and that recursive input will be the dry, cool air, which will be pumping into their tent to cool down the communications equipment they use to engage in what they do. So little information on that, and there's some references here. I can share this with anyone as well. So, anyone have any questions?
I got a couple. I'm curious about the angle. Did you just go with the way the trailer came, or adjust the axle so that you'd have the optimal angle?
We just went with the way in which the trailer is angled, and as it turned out, when it's leaning forward the other direction, it's very good during midday for a collection. At the end of the day, this is a very good angle, because if you try to make it so it goes steeper and steeper, eventually it's occluded by the horizon. There's also an issue with the sunlight transiting all the atmosphere. It adds an enormous amount of mileage that it goes through the air, and that interferes a little bit with collection. So to answer your question, no, we just went with the design of the trailer.
And then, given that you're already pumping water, have you considered, if you have excess water and excess power, actually trickling water on to cool the surface of the PV?
Yeah, and that's actually been used before. The issue is that it ends up shading and contributing to the hot spotting. So it would have to have a uniform sheet of water, and that would lend itself to other problems as well. But yeah, you're right on target. I mean, that's exactly the kind of innovations that we're going to see, is people address that and figure out how to ameliorate those concerns. Misting it, running the water on the backside, having a substrate that the water transits through would be another way. And this is a technology or innovation that people are working on right now for the macro scale as well. One of the ways in which they do it is they put on your existing modules, they'll attach a pan basically, and they pump water through it during the day. And this allows you to further leverage the ROA. It gives you radiant collection as well as electrical collection. So.
Can you talk about the hot spots dragging down the cell and then the array, the module, and all of that? You can't isolate that so that whichever cell it is, it's creating that hot spot is isolated and not dragging everything else down?
Yeah, and people do. There are people addressing that, and the way in which they do it on a module like this is there's 3 strings essentially in this module for the wafers, and they'll put in 3 diodes, and if one drops out, they'll just bypass that. And it's called bypass diodes, and so. And that's going to continue to be addressed. But what's happened is that the efficiency of the panels, everyone is saying, oh, we've got to get the efficiency up of the panel. But really what's happening is that the manufacturing process is getting better and better, and people are getting better and better at making the raw materials, the silicon, the wafer itself. And so those efficiencies are getting better, and they're better able to match the wafers and finding ways to decide which wafers are going to fail, which ones won't. So those are the ways in which I see that progressing and being addressed. So. You had a question back here?
Yeah, are you doing desal as well, or just purification?
We originally, the concept was to run a desalination, and that could be integrated depending on the customer's choice. But that was the impetus for the machine, is a constant electrical load like the desalination. And one of the reasons why we don't, in the CM4, the finished engineered product, we don't have the desalination or the water pumping on it, is we didn't have any capital. We didn't have very much working capital. And so Jim Starr and Jerry DeWitt suggested that we devise the Powerhead, what we called the Powerhead, and build that out so that we would have a demonstratable prototype. And in the circuit logic and in the drawings, we have the pump worked into it. But it could be any number of devices like that, desalination, the atmospheric generation uses the same technology. Reverse osmosis is the most common for desal, and so it uses RO, and then it uses a UV finishing, which is very common now too, even for desal. And that's again, that's going to be a commercial off-the-shelf product. I was approached by a company called Allotech here in North Carolina, and they manufacture sense and report automatic sense and report water purification systems now that do their own back flush, their own monitoring. The device is essentially standalone automatic, and they approached me. They wanted to find out where we were and can they manufacture that part of the equipment, can they manufacture the entire device, and have offered support. So. Any other questions?
Here. How much do you sell them for, and what's it cost you to build?
This unit we sold for $5,000, and the CM4, the engineered unit, we were selling for $6,500. We were losing money selling them at that price. We ended up pricing the engineered model at $8,999, and after the cost basis analysis, it turned out we were losing money at that rate too. So the cost analysis shows that we're probably going to be able to manufacture them about $9,200, somewhere probably between that and $10,500. But that's with a much more robust inverter at small scale and with 3 panels. Also a much more robust trailer. The military wouldn't even consider the trailer that we had chosen. So yeah, the manufactured cost in runs 10 units and under is going to be about $9,000. 20 units and over, we're probably going to be able to reduce that at least 25%, but more like 40% in component cost. So the sale price probably is going to be somewhere between $11,000 and $15,000.
What is your estimated size of unit by the time it's finished?
It will be the same footprint as this size, yeah. This one, the unit we have downstairs is slightly wider than this one wheelbase, but it'll be the same footprint. So it's 54 inches wide, about 8 feet long, 54 inches wide and about 8 feet long.
What volume of water can you generate?
This unit and this pump, we're pumping over 1,000 gallons a day in shunt mode. And we have a larger pump on a CM4. We retrofitted a machine that Rick bought. We retrofitted that with a larger 24-volt pump, and concurrently more volume can be pumped. So. Thanks, Mack. Yeah, thank you, and thank you all.